Good morning, majors. So today we're going to go over Unit 8, Day 4, which are going to be different types of quadrilaterals. We're not going to look at parallelograms anymore. We're going to look at trapezoids and kites. So these are not parallelograms because the opposite sides are not always parallel or not parallel. So this is just a warm-up. The first page is just a warm-up. We'll do that in class, next class coming up. So this one, we're going to look at a trapezoid and an isosceles trapezoid. The difference between a trapezoid and isosceles is a regular trapezoid is not going to have always equal sides, or they're called legs of your trapezoid, but an isosceles triangle will have equal legs, okay? So I made these, you can just draw a trapezoid, draw something very similar to this. So we're going to go over the sides. The sides, we're going to have only, the sides of the trapezoid, we're only going to have one pair of parallel sides instead of both pairs of parallel sides, like in a parallelogram. So we're going to say we have the base. These are called the bases. The bases are parallel, which means that our this is a symbol for parallel, and that means that our slopes are equal. So this top one right here is a base. The parallel sides are called the bases, and you're going to need this for the formula to find like the area and stuff like that. So the parallel sides are always the bases. So this is the first base. This bottom one here is also a base. So again, on this one also, right, this is a base. I did it in there. This is also a base. And the legs of my trapezoid, this is a leg. We call these legs, and this is a leg. Isosceles, same thing, but on isosceles, the legs are equal. So this one is equal to this one. And you can kind of tell that the bases are not equal. All right, the angles. We do need to know something about the angles. We know that if this is my parallel lines and this is my transversal, my angles are same side or consecutive interior angles, and they are always going to be supplementary, right? So there, we can say same side. And they're interior because they're inside or in between my parallel lines. So we're going to write that they're supplementary. So they're not equal, but they're supplementary. So they add up to equal 180. So that means that this angle and this angle add up to be 180, and also this angle and this one will add up to equal 180, okay? So they're not equal, but, and I'm going to actually write that they're not equal. So I'm going to say these two are not equal. So this one has 3 then, that's not equal, and this one's going to have 4. 1, 2, 3, 4. So none of the angles are equal to each other. However, let's look at the isosceles trapezoid. We still have the bases and the legs. We know that the legs are going to be congruent. So the legs, this leg, I have a little dash, is equal to this leg with a little dash. I know that my bases are parallel. You don't have to put parentheses around it, but they're parallel. Let's talk about the angles. Because my legs are congruent, I know that my base angles will be congruent to each other. So one arc and one arc means that they're congruent. And also these top angles right here, these base angles right here, put 2 arcs and 2 arcs. So these are equal to each other, and these will be equal to each other. So we're going to say both pairs of angles, let's say base angles, angle apostrophe S, are congruent. And we still have the same thing over here, same side, interior angles are supplementary. I tried supplementary. All right, let's talk about the diagonals. We do have something special, but it's only on the diagonal of the isosceles trapezoid. So I'm going to try it like this, I guess. Oops. So these diagonals are going to be congruent to one another. They do not bisect each other, but they are congruent. So we're going to say diagonals are congruent. Their measures are equal. Okay. Let's look at this. So it says the original statement in this case, this is a definition. If a trapezoid is isosceles, so this is, we always underline our hypothesis, and that's after the if. We write P. Then each pair of base angles, I guess, are congruent. Can I just write the congruent sign? You guys can spell it out if you want. But we underline our hypothesis and write P, and then I'm going to circle my conclusion, which is after the then, and then I'm going to write Q. The converse of that is if a trapezoid has a pair of, so the converse means we're going to flip it, so we have Q and then P. So we're going to start with Q. So if the trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So if you want to, since they're both true, then we can make a biconditional statement. So remember, we're going to have if and only if in there, which is already there. I want you guys to fill it in. Okay? Example 1, let's look at this. Let's try one. It says name the bases. And to name a side length, you know you're going to have two letters. A to B is a base because those are the parallel ones. The other base is D to C. Put a line above it. That's a side of a trapezoid. So you're going to have a line for a line segment. Name the legs. You guys can do that. What is the measure of angle A? So we know that these two angles, A and 130, have to add up to be 180 because they're supplementary. So 180 minus 130 is 50. So angle A is 50, okay? So I want you guys to try the other ones. And it is isosceles, so you know that my angles are going to be equal. 130, 130, 50, 50. Okay? All right. Another thing we're going to look at is a kite, and this is pretty much all of quadrilaterals. So the kite is going to be something like this. These two sides are going to be equal to each other. So I'm going to put this one is equal to this one, and these two sides are equal to each other. Okay. Let's look at the sides. We know that side, I'm going to name this, it says kite A, B, C, D right here. So I'm going to put A, B, C, D. Doesn't matter really where. All right, and I know that side AB is congruent or equal to BC. And I'm saying that the distance between A to B is equal to B to C without that line above it. That means the distance. And I know that the distance between A and D is equal to the distance between C and D. So I have two pairs of consecutive sides are congruent. So I'm going to say two pairs consecutive sides are congruent. Okay, let's look at the angles. This is something different. I know that angle A, and we can name that BAD as long as A is in the middle, is congruent to angle C. And that's all we know about the angles. So we have angles included in the non-consecutive sides are congruent. So angle A and angle C are going to be equal. And for my diagonals, I know that my diagonals are perpendicular. I'm going to draw in my diagonals. And maybe green, I guess. I don't know. Doesn't matter. Sometimes it doesn't work. Because So my diagonals are always going to be perpendicular, which means that they meet at a 90-degree angle. So this right here is a 90-degree angle, this one's a 90-degree angle, this one is a 90-degree angle, and this one is a 90-degree angle. So my diagonals are perpendicular. And I know that my shorter diagonal is bisected by the longer diagonal. So you can kind of tell this long diagonal is not bisected, right? Because this little part is a lot smaller than this long part. But this is going to always be equal to this. Okay, so I'm going to put 3. 3. So I'm going to say shorter Cupid is bisected. Shorter diagonal is bisected. So my smaller diagonal is this one. That one's bisected. What types of triangles are made by the diagonals? I want you guys to try it out. So what kind of triangles are made? These are examples. Let's try one. So it says, maybe this one, it says GHJK is a kite. Find H to P and G to K. So I know that if G to H is the square root of 29, then G to K is also the square root of 29. So this one's kind of easy. Let's look at what H to P is. Let's look at this triangle right here. So H to P is my X. And I know that this length is 5 because they tell me that this is 5. So what we can do is use the Pythagorean theorem. And I have to understand that this meets at a 90-degree angle. So it is a right triangle, and I can use my Pythagorean theorem. It looks like, since that's my 90-degree angle, that this is my hypotenuse. The purple one is my hypotenuse. So I need to say that 5 squared plus x squared equals the square root of 29 squared, because the square root of 29 is my hypotenuse. So that always has to be our C, right? So 5 squared is 25 plus x squared equals the square root of something squared. They cancel each other out. We just get 29. If you subtract 25, I'll just write it out for you. Minus 25. So we have x squared equals 4. And then when we take the square root of it, some of you guys left it as x squared equals 4, something like that on your test. Remember, you've got to take the square root of each side and get x equals 2. So right here, p to h is 2. Or h to p is 2. All right, guys. So try these out. We have a couple of examples. We will go over on how to fill in this Venn diagram in class. This part of it you already know. You did this in your last notes. This is a kite. We don't have any different types of kites, but for trapezoids you do. So we have regular trapezoids, and then we have isosceles trapezoids. All right, so I want you guys to fill in the rest of this. We have rectangle, rhombus, square, and parallelograms, but you filled this out in your last section. Have a great night, guys. Try to fill these out, and we'll see you in class tomorrow.